Here's your steam boiler. Here's your burner, Weishaupt burner. Your gas train over here. You got basically two. You got an SKP 15 and an SKP 25, which is a regulating actuator. Basically, just components. Low gas pressure switch. That's a VPS switch, so it's a valve proving, so it verifies that. So basically, as this is starting up, it'll open up one gas valve, pressurize the chamber, verify that basically you're not losing gas, so it verifies that those are gas valves are seating. Pilot regulator, pilot train, solenoids. Any questions on the gas train? No? Good? All right. So then we'll look at the burner. I'm just going to kind of go over all the components that are here. Obviously your VSD, variable speed drive. There's your flame scanner. That's a good thing to look at if you guys have flame failures or whatnot. It's always a good thing to pull that out, see if it's dirty, if it's positioned forward. Basically there's a set screw here. That thing will just kind of slide out. Make sure it's positioned. The lens is facing towards the flame, or where the flame should be anyways.
Do you recommend any sort of special cloth or anything, or how do you want that clean?
Usually just a cotton. Okay. I mean, I usually just use my shirt if it's clean. Nothing too big. It's your gas servo, your butterfly. Inside here is the brain, the LMV5, the Siemens burner control. Probably nothing that you need to get into on that. Yeah, all right. It's your air pressure switch. So basically that needs to verify that, make sure that that fan is running. You got your air sleeve servo over here. Basically what that does is on the actual burner, there's a whole sleeve that you can, that basically, this is how they control their NOx levels and their emissions. It's your whole oil train. Oil supply valves, oil return valves, your metering valve. This is all, a lot of boilers have air atomization. This is a pressure atomization. So the oil pump will actually pump this up to about 400 PSI into the nozzle to atomize it. Your oil pump is under here. And then you got your high gas pressure switch right on the manifold of the burner. Questions on that stuff? No? All right. Air damper, or your stack damper, that has to be fully open. There's end switches inside there that if that doesn't make that switch, the burner will lock out because it doesn't know that that's not open. I guess I should have gone over these when we were over here. You got two pressure controls up top. Those are kind of redundant. The one on the left is your high limit, has the manual reset on it. The one on the right's a redundant operator. So basically that one's set, I think, about 15 pounds above the boiler set point. So if the LMV5 doesn't shut it off on pressure, that one should. That one's an auto recycle. The high limit's a manual recycle. Low water cutoff, auxiliary low water cutoff, automatic recycle. If it drops down into low water and that water level comes back, it'll automatically reset itself. If the work or the auxiliary drops down, that's a manual reset. It has to be required. And that's what this little relay's for. If the red light's on, you're good. If it's off, you're not good. Water level controller, which controls your feed water valve. And then your Siemens pressure, differential pressure transducer that bases the water level off of that.
You want to talk about if they lose water here? What happens?
Yeah, so Always make sure that nothing on this is leaking, especially this reference line. If this loses its reference, your boiler's it's either not going to fill up with water or it's going to overfill. So that's a good thing to always verify, is that this isn't leaking. Don't pull the plug on either of them. And really, there's really nothing to do with that you guys need to do per se. There's really no serviceable parts. So the shunt switch, does everyone know how that works? So basically what this allows you to do is do a column blowdown while the boiler's running without shutting it down. So hold the button in, drop that water level down, and then slowly close that. Once that water level gets back up to normal operating level, you can release the button. So, any questions on that? You guys are easy. I know. So maybe we'll try to do a little bit better over here. Here's your control panel. This gives you all your information. Your touch screen is pretty much just making a visual of what is actually going on. There's really nothing in the touch screen itself that can be changed. The only thing that can be changed is you can do this program stop, which is a good troubleshooting thing. What this will do is you can actually go, that's going to hold the burner at pre-purge. That's going to hold it at pre-purge for the FTR. That's going to hold it at right before ignition. It's not going to light off. It's just going to drive to ignition and stop. That's your pilot. It'll hold it at pilot, hold it at main flame trial, hold it at post-purge, blah, blah. It's a good thing to check if you want to like check an air switch or see how your pilot is and see if you got solenoids that are popping open rather than going through everything.
So Justin, when they do maintenance, like their yearly or their annual maintenance, they can just put that into the fan mode, right? Just move air through there to help cool the boiler down quicker. They suggest
as long as the water level's where it's at. Correct. Once that water level drops, this won't run. So, yeah, I mean, honestly, the best way to cool a boiler down is drain it. I mean, even if you kick that fan on and you hold water in it, you got to think you're 85 psi, you're 340, 330 degree water. That's constantly just going to continue making steam. So the easiest way to get steam off and the heat out is just drain it. Now you lost my train of thought. Thanks. Yeah, so this basically just gives you all the information of it. If you click down here on this, where it's typically, we'll say lead boiler, lag boiler, whatever, that's another good thing to verify. All of these lights have to be lit up, basically for it to run. Right now the operating limit's not made because your burner switch is off, but you want to make sure it's on bus control, not in lockout, and the handoff auto switch is in auto, which is this switch from the boiler. Make sure that's always in auto. I mean, you can see all your information. You can't change anything on that, but you can see your feed water controller, all your alarms. There we go. This is all good stuff to give to whoever's servicing your boiler. Like if you call them up and say, hey, our boiler went down, here's what the code is. There's a code, there's an LOCC and an LOCD. There's a lockout code and a lockout code diagnostic. So if you look at the actual alarms, if you go into the manual of this, it'll give you the code and then it'll give you a diagnostic number, and then that will give you ideas to check. And if it gets over your head, that's always good information to give to a service tech over the phone or whatnot. Questions about this touch screen itself?
Yeah, you can't change any parameters on it, you said?
No. No, because all this, so when I set up that master panel, basically I locked any changes from this panel as being, so if you make a change, you can think you made a change, but when you exit back out, it's just going to revert back to what that master panel is telling it to.
Could we make it so we can see the header pressure on these panels?
No, that's only tied back into that the master panel.
So I noticed you left it auto on the screen, but you used the switch on here and put it off. That's the preferred method of.
The what?
So you put it off here, but you left.
Well, this was always off.
Oh, it was?
Yeah.
Oh. No, this one. So it wouldn't be on. Yeah. So is that the preferred method instead of putting it off here?
I mean, you can do that there.
Yeah.
I just my issue. I shouldn't have an issue with it, but if you just walk up to this boiler and you see that this burner switch is on,
yeah,
and you see that screen, and you're like, it's not running, a lot of people won't. Like, so if you did it, and then, you know, 12 hours later, you're not here, and some other guy comes in, sees that it's on, but doesn't see any display on the screen as why, then, I mean, you'd be able to tell by here, but I prefer to have something here where there's a visual. I mean, you guys, I mean, you can do either one. Yeah. So I'm just trying to get away from, I guess, nuisance issues or scrambling around on your guys' end. But yeah, you can turn it off there. LMV5, this is basically controlling the brain. This is basically the AZL is what they call this. This is communicating directly to the burner control. This, again, you can get into alarm history, so you can get fault history. That'll give you a code, the phase, and then it'll give you a readout of what it was. Status reset, that's where if you go into if you get a lockout, most of the time people are just coming up, hitting escape, clearing the lockout, and then you go on. If you don't want to clear the lockout right away and you just exit all the way back out, you'll need to go into status reset after the fact and reset it at that point. Manual mode. So manual operation, automatic, burner's going to modulate. Manual, it's going to only modulate to where you tell it to modulate. Another thing to remember is that even if this is a manual and it's in the sequence, it's still going to run as in the sequence, but it's only going to be in manual mode. If that makes sense. So if it's lag 1 and it kicks on and the master panel wants 80% out of it and you got it locked at manual at 20, it's not going to go above 20. And then burner off. So technically you have 3 ways to disable the burner. And that one's the easiest. So again, there's really not much you guys get it. So in order to get into most of it, you need passwords. You can get into a few things without the password, but again, it's not really going to allow you to change anything. So mainly just looking at crap. Is there any specific things that you guys want to know about this?
So when would you want to lock it into a manual set limit? Say 20%. Like, is there actually a purpose behind that? Or?
So a lot of it depends on, so like this, I can't remember if this has a, I can't remember if this has a belly switch on it or not. I think it does. Yeah, so most of the time, a lot of the boilers don't come with like a low fire hold or a belly temperature sensor. Okay. So if that's not tied into it and you just filled this up and your boiler's at 160 degrees and you kick it on, you don't want it to ramp right up to 100%. So that would be a good thing to basically go into that, hold it at 10%, let the boiler warm up before you release it. Okay. This is all automated through the belly sensor, that there is a low fire hold until that sensor's reached on it. So that's kind of the whole purpose behind them. And then it's also good to, when I'm running combustion and all that stuff, to increase it 10% of the time to kind of see what your numbers are, rather than just letting it go haywire. So.
What are the combustion numbers you're looking for on this stuff?
Weissop can basically say they burners can run 3% O2 throughout the curve, low to high fire. I never set them up that close, just because your air changes and everything else changes. This does have O2 on it, O2 trim, which helps with that. But I usually set them up about 4%, 3.5 to 4% throughout the curve. Yeah, it just gives you more of a safety buffer for it. I don't know if I'm missing anything.
How often do you recommend running fuel oil on it?
I mean, because you have nozzles in there that could get clogged up if they're, just sit idle forever. Yeah. I usually I would recommend like once a month. Just for maybe 10-15 minutes, just let them run. That keeps your oil fresh, that keeps your nozzles clean.
I think Josh at AVH runs it once a week, just briefly. Yeah.
So with that, we did put new nozzles in instead of trying to mess with cleaning those up for the maintenance every year. We're just going to change it.
Fair enough. Well, then if that's the route to go, then, because I know a lot of, and I don't know if Weissop's one of them, but I know a lot of other European burners just say replace the nozzle once a year. Every year replace the nozzle. It's recommended. Doesn't say you need to, but if that's what you're going to do, then if you're going to replace nozzles every year,
don't have to worry about it as much then.
I wouldn't worry about it as much. And kind of being in the hospital, I don't see you guys ever being curtailed to go to fuel oil. No, I mean, we just had that really cold spell, a month ago down in Denver, and like 80% of my non-essential customers were all curtailed to run on oil or turn your burners off, or pay extremely high prices, and not one hospital was called. So without like a catastrophic gas line failure, I don't see ever needing to really go to it. But does anybody know how to start it on oil?
Okay, go ahead here to the switch.
That's step one. That's step one.
I was hoping somebody else help me out. What happened to the key?
Yeah, where are the keys?
Yeah, let's see where's the key at. That's step one's find the key.
Right. So, honestly, it's turn on your system pump. We can fire it on oil if you guys want.
Sure.
Yeah. Why not?
Don't lose them. Where was it?
It doesn't say do not duplicate, so just go get some more made.
We do need to get more made. They're standard, right? We won't need them until we need them. Good.
Correct.
Yeah, exactly.
So, yeah, someone want to go turn the oil pumps on? Don't want to fire it on oil. We'll see if it lights off, what, 5 months after the fact?
It hasn't run in 5 months.
So, step one, kick your system pumps on. Step two, turn it to oil. 3 and 4. Supply and return lines. Verify you have pressure. And step 5. It's not going to call for it.
I'll go do it in bullet.
Now I can just put this in hand. We're good.
Yeah.
Another thing I should tell you. If it's in manual, it's going to ignore its set point. So it'll just run.
Keep going up.
It'll just run until that operator catches it on the other side. Why they do that, I don't know.
Luckily, I think you've left this at 10%, so.
The what?
Your manual rate, I think, was at 10%, wasn't it?
0, but yeah, 10%. That's where it's at. But that can also all be changed.
Yeah, don't change it, or leave it at 0. So 0 is a 10% fire rate?
In essence. So I'll just show you this then. So if we do this, you have to hold this supply for more than 1 second. So hold it until this appears. It doesn't always communicate and show that it changed right away. But if I come over here, I don't think it's going to allow me to do it. No. Well. Anyways. There you go. So now it's locked at phase 36, which means your servos and everything are going to drive to ignition and hold. It's not going to light. It's not going to try to do anything. And then you'll come up here and you'll basically get a warning, program stop. This is going to sit there now. So, the pilot lit. Look at that. So your ignition position and your low fire position are different. So just heads up. So if you ever see it light off and you got it held in low fire and you see that it start increasing, that's because your point 1 is different than your actual ignition. And it still looks good. Yeah. Anybody want to see an oil flame?
Just looking at the flame.
You can see the flame a little better on oil through that. You can't see it through gas. But the back view's better.
What do you have the ignition on this?
What do you mean?
What fire rate, basically?
What do you mean?
It doesn't ignite at low fire.
No, it's an actual special position where I set servo and air. So I don't know what you mean by what position.
Okay, I was wondering if you set it to somewhere, but no, it just finds its sweet spot and then ignites from there?
Well, no, it's set. There's an ignition point that is set in there.
Okay.
And it's a matter of trial and error when you set them up of where you exactly need your air and your fuel and all that.
All right, I understand that.
To get it to light off.
Well, I noticed your set point's at 90 now. Normally it's at 85.
Yeah, that's because I basically took it out of remote. I got it local right now. By going into hand, on this, it's basically running locally here.
So local is set to like 90 is your set point.
Yeah, and that's going to be in your operation, your boiler set point.
Okay.
It's going to run on W1 when it's not being communicated to by.
Now, is there a reason why you have the set point remote, or when you have it in hand higher than what they'd call for off the height over there? No?
I think you can drop it down.
Okay. Just curious if there's a reason.
No.
I mean, ideally, we never have to run things in hand.
So I mean, I can change that right down for you.
Well, he said he wouldn't stop at that point anyway.
But that's, if it's in hand, it won't.
It'll just keep going.
It'll just run.
Yeah. Okay. So that's that point. It just looks pretty.
In essence, but I mean, if it loses communication with the master panel, it's going to run that set point.
Okay.
So
that's what, when it loses communication, that's what we'll do. Okay. That makes sense.
Oh.
Yeah, you can change the point. Can you show me how to change the output level? So you have it locked at 10%, you said?
So that's manual operation, set load, and then as you increase this up, so I mean if I go,
so 0 to 10 is just 10?
yeah, it's just.
Alright, and then that's how I can do combustion. It's on this screen, 10%, 20% throughout this range.
That will just give you your numbers. That's not going to, you have to have a whole password to get into the actual combustion ratio control. Because yeah, you can basically take this up through its combustion points, or through its percentage, 10, 20, 30, whatever. But in order to make changes to your servos, you have to have a password to get into that.
I can at least take a combustion analysis though. You can do it, yes. You can take it in 10, 20, 30, and we can compare it to his numbers. We have his numbers. We can say, yep, it's good, move on. And they are coming out in the first year to do this with you.
So yeah. And yeah, you get an orange flame versus a blue flame.
I was going to say it's an orange flame on fuel oil. It's the little thing, right?
It's the little things. It's the little things. Any other questions? Surge tank, condensate receiver, whatever you want to call it. All your condensate that you are bringing back basically dumps in here. You got a low pressure steam makeup through your regulator to heat this water up. Basically this tank just feeds your DA tank. 2 surge pumps here that basically run off of pressure. Well, not even that. I don't know why they have pressure sensors on here, to be honest, because there's not a VFD to run up and down. So one pump's on, full throttle. And then as the DA calls for water, it'll open up this butter for this valve here. So this actuator is controlled by that controller, which runs off of that differential pressure switch on the DA tank, controls that. So high water alarm, low water cutoff. The pumps will stop running if it gets to that point. Questions?
And this is the one, if things went bad, we can live without the surge tank, right? We can actually have the surge tank feed strictly off our DA tank.
I believe you have a bypass that you can actually feed from the surge tank to your boilers.
We can go from the surge tank to the boiler. Yes, you can. Okay. I know we can do it just in the DA. Yeah, so when we go to take that down for maintenance at the end of the year, we're basically going to switch over and our surge tank is going to be your one. Okay. That's clear. Just in case. We're worried, just in case something when they go down here. Yeah. We can be off the DA, but I never knew we could be off the surge tank.
Yeah, so if your DA craps out, yes, this will feed your boilers.
Okay.
Possibly. I don't know what the... These say they're putting out 98 pounds. I don't know if they're actually putting out 98 PSI. That might be the one thing you might you might have to drop boiler pressure down a tad bit in order to get water into them.
Okay.
But again, that's just going to be a trial and error type of thing if it ever gets to that point. But I guess when we switch over, you'll be able to tell.
Middle of summer. And it's in the summer that we're doing that anyway, so it should be minimal load.
Not many people like to do them in the middle of summer.
Still get a load though. That's it on that.
Yeah. There's your DA tank. Same concept as the surge, except this tank is under pressure. It's usually between, I think this one's about 9 psi. Should maintain about a 220, 230 degree temperature on it. Again, low water control. Low water kills your pumps, high water alarm. Differential pressure switch again for your level. And that's the switch that's controlling that valve up the surge tank to fill this up. Emergency makeup valve in the back that MTech wired in after the fact, which is nice of them. Basically how this works is there's a spray head in the top that your water, basically your water from your surge tank dumps in. This basically goes through the spray head. As the steam comes up, deoxygenizes the water, and then there's a vent out of the tank. Basically there's a gate valve on top with a hole drilled through the gate. That's about an 1/8 inch. It's usually about an 1/8 inch, might be a little bigger depending on the application, which then allows that oxygenated steam to escape the system. So you do lose some, so you do lose some efficiency, but you also get most of your oxygen, a lot of your oxygen out of the water.
So it's just an orifice, it's something that closes back up?
No, it's constantly open. Yep. It's constantly open.
One of the things we pulled these handles, these got open.
Oh.
And of course, this is the same thing as on your boiler. If this line gets empty, you're going to breathe like 17 inches full, and it's going to be empty, and you're going to be like, what the heck's going on? It's going to be full, and it's going to show that you need water. So then you've got to, of course, fill this line back up on the top. So just make sure nobody puts these back on or opens these two valves. That was what we were doing.
That's a sample. This whole thing?
Yes.
It's sample cooler. So basically what this allows you to do is take water from your tank, goes through here, you got city water, cold water, goes through here, cools it down, you can put it into a tester.
So it's a heat exchanger? It is.
In essence.
It doesn't mix it, right? It's separate. The city water will be separate from...
Yeah, it just cools down your DA water so you can actually go test it.
Chemical testing. Okay.
And you got your steam PRV here that's knocking your 85 psi down to 10 for the DA tank. Questions? Yeah, you guys probably know negative is below set point, positive is above set point.
0
Yeah.
Now, would this view water switch actually do anything without changing the valving? I mean, what would that even do if I changed the view water from DA to surge, but didn't touch any valves?
It's a good question.
That is a good question.
It's a good
So
question.
would that be something we should kind of
A lot of good questions,
put a cover over or something maybe? Or?
Again, I don't even...
So I wonder, I mean, what did you do?
No, because your pumps are going to run regardless.
Yeah, that's what I mean. I mean,
To be honest with you, I want to say that switch is for more of a on-off pump operation versus a modulating feed water and all that. So if you do switch it to surge, you'd have to do wiring in there. So when your boiler actually called for water, it sent the signal to your surge pump starters versus your DA tank pump starters. That's my guess. I can look into that and get back to you on it.
Yeah, because right now they're either valving, maybe valving, you know, where we closed the valve and opened it, and now you're feeding from your...
You could probably use that switch to use a motorized valve up top. There you go. There's some more work for you.
Just don't touch it, motor. Even where it's at, we're good.
If you have to use the bypass, you're going to have to kind of watch it 24/7 because you have nothing regulating pressure at that point.
You say if we bypass the surge.
So if you bypass your PRV, if your PRV were to fail,
then it's not going to
There's nothing to regulate it, so you'd be introducing system steam into your tank.
PSI steam versus 10 PSI.
And that safety valve will lift at 50, so that's not that loud though. 50 is not too bad.
Everybody good?
Thank you.
Thanks, guys.
Thank you.